Hi everyone, this is Mayuri Khinvasara Khabya, Developer Relations Engineer at Google, and we have Brian, who's the Android TV Media Lead at Google. Thank you for tuning into this session where we talk about creating engagement and high quality playback on Android TV OS and Google TV. In 2020, the usage of smart TVs has increased by 157%. Not only this, but the breadth of content that is being accessed is also larger than ever. With this new influx, it is important to engage with these new users and delight them with a great playback experience. So, you've got users and you've got great content, but how do you actually connect them? Typically, when users switch on their TV, what they see is a home screen. Now, from your home screen, how do your users actually reach your TV app? There can be multiple entry points via the apps list, assistant, etc. One simple way is a user browses content on the home screen and then just clicks something to start watching. Now you've got the users to come to your app once. How do you take it ahead from there? You have great content and you would want your users to keep coming back to the app again and again to watch your content. So, how do you engage with them? There are multiple ways to engage with your user from the home screen. As app developers, one great way to create engagement is by integrating with the Watch Next row. Imagine after a long day, you come home, grab some popcorn, and switch on your TV. What you see there is the home screen, and right there is the Watch Next row. The Watch Next row gives you a chance to talk to your user even without them explicitly opening the app. Watch Next is uniquely positioned on the home screen to increase engagement by recommending unfinished and relevant next content. With the increasing number of apps today, it is even more important to showcase the most relevant content to engage your user. The Watch Next row is called the Play Next row on Android TV. It enjoys top of the line placement on the home screen. Apps can add, update, remove relevant content from the home screen to re engage with the user. In Google TV, the Watch Next row is called the Continue Watching row. Even though the look and feel between Android TV and Google TV is slightly different, there is no extra effort required from the developer side, as the API implementation remains the same. For Google TV, we have a quality certification process for apps to be able to add content to the Watch Next row. More details on this are also available in your developer documentation, so I do recommend you to check that out. So, what does the user exactly see in this Watch Next card and why is it so engaging? You're watching a long movie and for some reason the user has to live in between. And you would want the user to come back to your app sometime later and finish watching what they started. How do you make that happen? You give us the right metadata and we create a beautiful card with all information and direct call to actions for the user. To show the progress bar, you set the last playback time and the total duration. All this was about the unfinished content. Now, what if the user has finished watching the current TV episode? We also have a next card so that you can suggest the availability of the next episode to your user. So, we've seen two important CUJs, resume and next until now for engagement. How do you actually use them? The first type of watch next is the type continue. Imagine a case where the user started watching something, didn't like it, and went somewhere else in like a minute or so. Do they want to see this content again on the home screen, which they already left? We've set some guidelines as a minimum threshold to consider when a video has started, and only then a card should be added. All these guidelines can be found in great detail in our developer documentation. You can use the watch type next to recommend the next available episode of a series or a season. The watch queue indicates that user can start playback instantly from the home screen itself. Okay, do we have more options here? Yes, in case you have a new season available, you could use the type new to indicate that. Adding the relevant type to Watch Next program makes the engagement better with your user. Do you remember a time when you found some interesting content and thought, oh, I definitely want to watch this? Let me probably bookmark this and watch it later. Yes, you can do so by adding the type watch list. And one more thing, the more metadata you add, the more seamless your user experience and the better your user engagement. Some metadata is not directly visible to the user but adds great value. For example, adding the right deep link URL to start playback instantly. Add the internal provider ID matching with your content ID for seamless experience across all surfaces. Add the right engagement time when the user started watching. If you want the Watch Next card to start previewing the video, add the preview URI. What are different kinds of content that you can add? You can add movies or episodes. Remember, the motive here is to suggest content which is relevant and that can help you re engage with your user to enable your user to come back to the app. You shouldn't include short content like clips, teasers, trailers, etc. Now that you know how can the Watch Next API help you create engagement, let's see how do we actually implement the API. The Watch Next program follows the builder design pattern. Very simple and easy to use. Just add all the necessary metadata to the builder. For different video types, for example episodes, you can add more relevant metadata. The more information you add, the richer experience we can give to your user. For doing insert, if you love working with content providers and cursor operations, you can insert it directly. But we also have a helper class, the preview channel helper, which does all the cursor implementations, synchronizations, everything under the hood. You can insert directly with the publish API. The publish API gives you back a program ID, so you can use it later to update your content or synchronize within your app. There is a long movie and the user is watching little every time. So you want to go back and update the progress bar every time the user leaves the content unfinished. You can do so by the update API. Remember to use the same program ID that you got in the publish API. If you want to remove an entry that the user has finished watching, you can do so by the helper function from the preview channel helper or use the delete API from the cursor. We recommend batch operations over individual cursor operations. The performance implications between the two approaches really does make a difference. Now that you know how to implement the API, let's look at some guidelines to make sure your implementation is as good as possible. The more rich information you provide, the more delighted your user is. We recommend some threshold guidelines to understand when the video has started playback or ended. All these guidelines are also available in great detail in our developer documentation, so please check that out. If you want your user to watch the next or new content, be nice and remove what they've already watched. Don't spam your user by keeping stale content on the home screen. So far, so good. What are some ways you can accidentally break this experience? You should not add short clips like teasers, trailers, etc. Imagine a time you started to watch an episode. Few minutes into the episode, you realize, oh, you've already watched this. You go back and start playing some other episode. Be nice and keep only the latest episodes in the Watch Next row and delete others from the same show which are already added in the Watch Next row. And also, don't spam your users with all the content that you have. Give them exactly what they love watching, that is, content they have already interacted with in the past. All this guidance is also available in great detail in our developer documentation, so please check that out. So, how has Watch Next worked in the real world? Let's see some success stories. Hotstar is a top global app and they've seen great results by integrating with the Watch Next API. Over 25% of their TV app engagement is driven from the Watch Next row. MX Player is a top global app, and they saw 26% of their daily active users coming to their app through the Watch Next row. Additionally, 29% of their engagement is coming from the Watch Next row. We have some great resources in our developer documentation and also code lab for you to continue learning more. Thank you. And next, I would like to invite Brian to talk about high quality playback.
Great. So the user is now engaged and wants to watch a movie or show. Your server likely has multiple video streams of varying quality for the content selected by the user. Adaptive streaming will ramp up and down the bitrate and resolution of the video to adapt to the network bandwidth. However, how does your app decide what is the highest quality video and audio stream that can be handled by the user system? Let's do a deep dive into discovering the media capabilities of an Android TV device. The TV experience has additional considerations beyond just what the Android device can do. The user's device could be connected to a budget, low-end TV, or the latest and greatest TV on the market. It may be connected to a soundbar or even a surround sound system to create a more immersive experience. You want to give the user the highest quality playback that works on their entire system. You'll need to consider what video decoders are on the device, whether or not the user has a surround sound system, whether or not the user's TV can support 4K or high dynamic range, creating a more detailed, colorful, and rich image. And after the streaming and playback has begun, what happens if something changes? To save bandwidth, videos on your server are compressed into an encoded format. This compressed video will need to be decoded. The app needs to determine not only which decoders are available on the device, but also how performant they are. For example, the device may not be able to decode high bitrate video at a resolution of 4K and a frame rate of 60 Hz. Like with mobile, the performance of video decoders on Android TV devices vary greatly. First of all, the app needs to determine what decoders can be used. This is done by looking at the MIME types. Decoder and encoder algorithms are improved over time. Each major advancement in decoder technology is represented by a new profile or level. While the format may be supported by the decoder, it's also important to know if the decoder supports the algorithms that were used when the video was encoded. Now we get to performance. Can the video decoder handle the resolution and frame rate of your video stream? Or will the device be overwhelmed if it tries to decode 4K resolution at a frame rate of 60 Hz? Finally, the bitrate of your stream must be considered. Bit rates define how much data is present in the encoded video, as well as how much data must be processed by the decoder. The higher the bit rate, the higher the quality. However, higher bit rates may require higher performance video decoders. It's important to know if the decoder on the device can handle the bit rate of your stream. Finally, the app needs to determine if the features it wants to use are supported. Does the video decoder support secure playback? Does it support tunnel mode? Does it support adaptive playback to adjust the network bandwidth usage on the fly? Great! Now we know we can decode the video. What about the audio stream? Like video, audio can be coded in any number of formats. However, the formats are often different than on mobile. On TV devices, Dolby and DTS audio formats are common. These formats don't have to be sent to an audio decoder, and instead can be sent directly to Android. However, before sending these formats to Android, it's important to know if the audio playback device, such as a soundbar or headphones, supports these formats. The Android device could be connected via HDMI to an AV receiver that supports Dolby Atmos, Or perhaps the audio is being sent over HDMI ARC to a connected soundbar, where only PCM stereo, Dolby Digital, and DTS are supported. Or perhaps the user wants to listen without disturbing a sleeping baby, and their headphones only support a simple stereo stream. Assumptions must be made by the app about which audio playback device will be used. For example, prioritize Bluetooth headphones over HDMI so that when the user turns on their headphones, they will hear the audio over the headphones and not their speakers. Note that sometimes this assumption can be wrong. An audio track creation failure should be handled by falling back to a PCM stereo stream. We are improving this in future Android releases so that the app no longer has to make assumptions. Once the playback device has been identified, the app can examine the supported audio profiles or audio encodings. This information can determine whether or not the formats, like Dolby Atmos, can be sent directly to the audio track. Android TV displays are generally more capable than phone displays, with HDR and 4K resolutions being common. However, not every user has a newer TV. Some users have TVs with resolutions as low as 720p, without any HDR capabilities at all. First, determine the maximum resolution that should be streamed. Examining the current display mode will tell you the width and height of the display in pixels. Setting a higher resolution than this will not result in a better image. While there are many APIs that can tell your app the canvas size, only the display mode returns the video resolution. This is because some Android TV devices pair low-resolution graphics with high-resolution video to save on cost. Next, the app should use Get HDR capabilities to determine if the display supports high dynamic range formats, such as Dolby Vision or HDR10. Just because there is a video decoder that can decode these formats doesn't necessarily mean that it can be displayed. For example, an Android TV set-top box could be connected to a standard dynamic range TV. Stuttering can occur when playing 24 frames per second content, like movies, on a display running at 60 Hz. This is because some video frames must be displayed longer than other video frames to be able to convert from 24 Hz to 60 Hz. While this may not be noticeable on phones, it can be very distracting on the big screen, especially in scenes with slow panning shots. Use the Set Frame Rate API to change the display's refresh rate to a multiple of the content frame rate. So each video frame is displayed for exactly the same period of time on the screen. Use the Change Frame Rate Always flag so that non-seamless refresh rate switching can be supported. What is non-seamless refresh rate switching? The HDMI wire protocol can cause older TVs to flash a black screen for 1 to 2 seconds when switching refresh rates. While this is disruptive to the user experience at the beginning and end of playback, it can result in smoother video playback during the video. While this feature is disabled by default in Android, there are some users that are okay with the disruptive experience because they prefer the smoother video playback. Using the Change Frame Rate Always flag allows these users to opt in to non-seamless switching via device settings. Since it can be quite disruptive, we recommend only performing non-seamless switches for main content like movies and TV shows, and not short video clips like trailers. We also recommend showing a message to the user right before switching to let them know that the black screen is expected. The app can detect whether or not a switch will be seamless by examining Get Alternative Refresh Rates on the current display mode. If there are alternative refresh rates and the video frame rate is a multiple of one of them, the switch will be seamless. Android may switch to a multiple of the video frame rate. For example, an alternative refresh rate of 48 Hz may be used for content that is filmed at 24 frames per second. The higher refresh rate provides the user with smoother animation when interacting with the user interface. Great. The refresh rate of the display now matches your content, and smooth, high-quality HDR playback at 4K can begin. But wait, what if there isn't enough security on the device to play back the encrypted content? Or what if the user connects Bluetooth headphones halfway through the show? Let's discuss these topics in the next couple of slides. Some of your video or audio streams may be protected by DRM encryption. In order to decrypt on the device, it's critical to know what limitations are imposed by the license file. The license will likely require a minimum HDCP level from the device. The app should not stream anything that requires a level of HDCP protection that the device cannot satisfy. Otherwise, decryption will fail. So, decryption works, and we've correctly detected capabilities, and it's playing 4K HDR video in Dolby Atmos. But what if the user is comparing a new TV to their old TV and wants to see how much better the new TV is before they spend for a top dollar TV? Or what if the user connects Bluetooth headphones because their baby is going to bed? Listening to callbacks for display changes and audio device changes will allow your app to handle these dynamic changes to the user's system, even while in the middle of playback. When Bluetooth headphones are turned on or off, or perhaps the user's soundbar is turned on or off, the app should re-evaluate the audio considerations discussed in previous slides. If the current audio stream is not supported on the new playback device, or the new playback device supports a higher quality audio stream, then this new audio stream should be buffered and swapped in. An audio cutout during these sorts of events is expected by the user, so stopping video isn't necessarily needed. Consider also when a user swaps their display, or perhaps changes settings in the TV menu that causes, for example, the HDR support to change. In such a scenario, the app should detect the display change and re-evaluate the display considerations discussed on previous slides. If the current video stream is not supported, or there is a higher quality video stream that has now become supported, then the current video stream should be stopped and the new video stream should be buffered. It is not recommended to continue playback in this scenario, since video playback will have to stop anyway, and the video dropping out briefly is not expected by users. Let's talk about badging next. You just spent all this effort getting your app to robustly play the highest quality audio and video streams. Let the user know they are getting the best. Badging on the content details page will let you know that your content is available in a high quality format like Dolby Vision and may influence their decision on whether they watch or not. And once the user has decided to watch your content, they may be confused about if they're getting the best quality possible. Often users don't know if they're getting 4K or HDR. They might be paying a lot of money to get the best. Let them know that they are displaying badges in the upper right-hand corner or upper left-hand corner for the first few video frames. Great. Your app works well and shows beautiful content with the latest Android release. But Android TV devices aren't updated as frequently as phones. If you don't think about older Android TV devices, the success of your app might not be realized outside of the lab. Let's talk about some common ways to handle various issues on older devices. Android X provides some great tools for dealing with older Android releases. Android TV devices haven't always reported their video resolutions accurately. Using the display compat library will ensure that your app properly detects support for 4K. It's also important to think about refresh rate switching on older devices. We've only just started certification of this feature on Android TV devices. Your app will need to use preferred display mode ID on older devices in order to support non-seamless refresh rate switching. Android was built for phones, and as such, there is a strong assumption that the display does not change. For Android TV devices like set-top boxes, this isn't true. We only just started certifying behavior for display changes in Android 12. So it's usually best to reboot older set-top boxes when testing your app across different TVs. Finally, the Get Audio Profiles API is new. The Get Encodings API found in older Android releases is not fully sufficient. For example, if your audio playback device supports different sample rates between PCM and Dolby Digital, your app may need to use Is Direct Playback Supported to determine which sample rates are truly supported for each PCM and for Dolby Digital. It's great you want to create a robust app using what we've taught you here today. However, we recommend using ExoPlayer to save a lot of time, since it handles a lot of complexities around AV sync and versioning, and even handles peculiar behaviors on problematic devices. In this section, we'll discuss some additional techniques to help you use ExoPlayer to its full potential. The track selector in ExoPlayer examines the contents of your manifest file and determines which audio and video stream should be played. If you are having problems with the right audio and video stream being selected, consider customizing track selector. ExoPlayer does not assume anything about the HDCP protection required for your Contents DRM licenses. It is up to the app or the server it talks to when deciding what quality of video streams require what level of HDCP protection. ExoPlayer doesn't yet support non-seamless refresh rate switching, but it does do seamless refresh rate switching. If you integrate your app directly with non-seamless refresh rate switching, as discussed on previous slides, you'll need to disable the seamless-only refresh rate switching in ExoPlayer. This can be done by calling setVideoChangeFrameRate which was added to the ExoPlayer class in version 2.15. As of release 2.15, ExoPlayer enqueues buffers to the video codec and sends decoded video frames to the screen in the same thread. On some devices, this can cause stuttering if your stream contains a video frame that is too slow to decrypt. Enabling a couple of experimental features will change the threading model so that one thread is used for queuing and a second thread is used for rendering. This can alleviate playback stutter problems associated with decryption. Note that separate threads may expose race conditions in older devices, so experiment with this feature before rolling this change to all Android devices. Well, here we are at the end of our journey. I hope you enjoyed our presentation on increasing user engagement and increasing playback quality on Android TV. We look forward to hearing about your experiences with creating apps on Android TV and wish you all the best.